Today we're going to look at lesson 7-2, solving exponential equations. And these are essentially equations that have a variable in the exponent. So this entire unit is about procedures, procedures, procedures. If you learn the procedure of what to do in a particular situation, the math is not that difficult. So here's your procedure that you're going to follow when solving exponential equations. And of course, I'll go through this in detail in a minute. So you're going to use any of your properties of exponents and simplify each side of the equation. So if you're multiplying like bases, you add your exponents. If you're dividing like bases, you subtract the exponents. If you have a power to a power, you multiply exponents, and so forth. So our very first, and I'm only going to do the evens on these notes. If you want to see the odd answers, you just need to go to my website. The notes are listed there, and you can practice those and then check your work. So as we look at this, our whole goal is to, once we get one power on one side and another power on the other side, then you want to rewrite the equation so that both sides have the same base. So see how this power has a base of 5 and this has a base of 5. That's what we want to see on each side. So if you look down here, this has a base of 2 and that has a base of 8. We want them to have the same base. So I'll teach you how to get those to be the same. Then finally, logic reasoning shows that if this power is exactly equal to this power and they have the same base, logic reasoning says that their exponents are going to be equal. So we will set the exponents equal to each other. So let's go ahead and do that for equation 2. So essentially you can just kind of forget about the bases and just take the exponents and set them equal to each other. And then you're just solving algebraically. So you should focus on your variable terms first. So I'm going to subtract an n. I get 3n plus 5 is equal to negative 7. I'm trying to solve for n, so I'm going to subtract 5. So I get a 3n on the left and a negative 12 on the right. Divide by 3, and you get n is equal to negative 4. So if I take negative 4 and plug it back in here, 4 times negative 4 is negative 16, plus 5 is negative 11. And if I put negative 4 in here, negative 4 minus 7 is negative 11. So 5 to the negative 11th is exactly equal to 5 to the negative 11th. All right, so for number 4, we have something slightly different. We don't have one power here and one power here. We have 2 powers and 2 powers. So you've got to use your exponent rules in order to make this side 1 power. So we are multiplying like bases. So that means we are going to add the exponents. So I'm multiplying like bases, so I add the exponents. And that's going to give me 1 power on the left. So I'm going to do the same thing on the right hand side. I'm multiplying like bases, so I'm going to add these exponents. So all I did was take this and add it to this, and you can combine it as 1 power. This, add it to this, and you can combine it as 1 power. So you end up with 10 to the 5th is equal to, collect like terms, you've got 10 to the 3v minus 7. Now that you have like bases, you can set the exponents equal to each other because they must be equal. So 5 is equal to 3v minus 7. Now all you have to do is use your algebra to solve for the variable. And then divide by 3. And we get v is equal to 4. All right, now for 6 has an issue because I don't have like bases. So you have to look and think to yourself, always go with a smaller number. And that number is 2. Can I make this bigger number 8 into a power of 2? I'm not going to be able to make 2 into a power of 8 because you can't take a power and make it a bigger number than what its current power is. But remember, 8 prime factors into 2 times 2 times 2. So I can actually replace 8 with 2 to the third. And so the left side is 2 to the p minus 7. And so now that I have like bases, I can set their exponents equal to each other. So p minus 7 is equal to 3, and this is a very simple solution. You just add 7 to both sides, and you get p is equal to 10. So what I would like you to do is pause the video, and I want you to solve 8 on your own, and then restart the video and see if you were correct. So always look at the smaller number 2. Can you take the bigger number 32 and make it into a power of 2? If you prime factor 32, you will get 5 2's. So 32 can be replaced with 2 to the 5th. And now that I have like bases, I can set their exponents equal to each other and use my algebra to solve. And I get m is equal to 7. Number 10, you actually have 2 ways you could solve this. So 4 is a smaller number, so the question is, can you make 16 into a base of 4? Yes, because I can prime, or I'm not going to prime factor 16, but I can factor 16 into 4 times 4. So 16 can be replaced with 4 squared. You could also break this down into 2 squared and this down into 2 to the 4th. So you could make common bases of 2 or common bases of 4. Making common bases of 4 is less work. So I choose to do common bases of 4. And instead of 16, I'm going to replace it with 4 squared, and then that's still raised to y minus 3. And so let's review power to a power rule. So this would be like having 4 to the 3rd to the 5th. If you have a power to a power, remember you just multiply those exponents. So you would end up with 4, 3 times 5 is 15. So we're going to apply that same concept here, but we're going to take the 2 and multiply it to all of the y minus 3. So we're going to have to distribute this 2 throughout there. So you end up with a 4 to the 2y minus 6, and then the 4 to the y plus 2 stays the same. So y plus 2 equals 2y minus 6. I can now set the exponents equal to each other because I now have like bases and 1 power on each side. So I want to move my smaller y first. So I end up with 2 equals y minus 6, add 6, and you end up with y equaling 8. All right, so let's look at 12. I want you to pause the video and I want you to attempt 12 on your own and then restart the video and see how you did. All right, so again, you're going to ask yourself, here's a smaller, can I turn 16 into a power of 8? No, because 8 to the first is 8. 8 to the second is 8 times 8, which is 64. So I can't do that. I can change that to a power of 4, but I can't change this to a power of 4 because 4 times 4 is 16, not 8. But I can change them both into a power of 2. So sometimes you have to change both of them. So in this case, I'm going to change 16 to 2 to the 4th and 8 to 2 cubed. But remember, this is still raised to the 3x. And this is still raised to the x plus 2. All I did was exchange 16 with 2 to the 4th and 8 with 2 to the 3rd. Power to power, we have to multiply these exponents and multiply these exponents. So we get 2 to the 12x equals 2 to the 3x plus 6. Now that I have like bases and one power on each side, I can drop the bases and set the exponents equal to each other. Then we need to get our x's on one side, so I'm going to subtract 3x. And I get 9x is equal to 6. Divide by 9. And then I want the reduced fraction. Do not give me a decimal answer when your variable equals a fraction. And so here I can divide both the top and the bottom by 3. So my reduced fraction is going to be x equals 2 over 3. So with 14, we have a little situation that looks complicated because you have this fraction here, but it's really not that complicated. Remember, this is 3 to the first, and if I don't want it to be a fraction, I want my base of 3 to be up here in the numerator. Remember, if I switch that out, 1/3 is equal to 3 to the negative 1. Anytime that you put a base and its exponent in the opposite direction, so if I move it from the denominator to the numerator, that exponent changes sign. Same thing if it were up top in the numerator and I pushed it down to the denominator, it would change signs. So if I had 1 over 9, I would make that 1 over 3 squared. And then if I moved it upstairs, that would become 3 to the negative 2. So we're going to use that concept here. So I'm going to change, so this already has a base of 3. I'm going to change this to a base of 3. So if you prime factor 81, you will recall that it has 4 3's in it. So 81 can be replaced with 3 to the 4th. It is still raised to the 2x plus 5 equals, I'm going to replace the 1/3 with 3 to the negative 1 as we just discussed, but it's still raised to the 2x. So now we have a power to a power like we had in the last problem and a power to a power. So we want to multiply the exponents. So I want to make sure that I distribute this 4 all the way through. So I get 3 to the 8x plus 20 equals, and then I'm going to multiply negative 1 to 2x. So I have 3 to the negative 2x. You have one power on one side and one on the other, so you can drop those like bases and set the exponents equal to each other and solve. So I'm going to move the 8x to the right, and so I get 20 is equal to negative 10x, and then we're dividing both sides by negative 10, and so x is going to equal negative 2. So I would like you to try number 16 on your own, so pause the video, do your best, and then restart it and check your work. All right, so your main goal is to figure out what can I make these both into. So always start with a smaller number, 27. So 27 we've used a lot, and 27 is 3 to the 3rd power. Now mind you, it's still raised to the 2x as well. So that tells me that it's highly possible that 243 has a bunch of 3's in it as well. So off to the side, I'm going to take 243 and I'm going to prime factor it. So I'm going to start with 3. 3 goes into 24 8 times and into 3 once. So 3 goes in there 81 times. 81 is 9 and 9, and each of your 9's has 2 3's. So we have 5 3's all together, so I can replace 243 with 3 to the 5th. But remember that it is also raised to the x minus 2. So now we have a power to a power here and here, and so we have to multiply exponents. So on the left we get 3 to the 6x equals, and on the right we get 3 to the 5x minus 10. You have to remember to distribute that all the way through. Because I have like bases, I can drop the bases and set the exponents equal to each other. And the solution is simple enough. Just subtract 5x, and you end up with x equaling negative 10. Good job. All right, so this one involves both the fraction and two bases on one side. Remember, we only want one base, and we have to have all the bases the same. So I know I could change this to 3 squared and 3 squared, and I could change this to 3's. But I could also change 81 into just 9 times 9, which is 2 9's, and then I would have less work. So 81 becomes 9 squared. But I don't want 9 squared in the denominator, I want it up in the numerator. So that means that this side becomes 9 to the negative 2, because I want to move this up in the numerator and have just a power. And so on the left, I need to multiply like bases, so I add the exponents. So I'm going to have 9 to the 2x plus 4 plus the 2x. If I collect like terms, I have 9 to the 4x plus 4 is equal to 9 to the negative 2. Now I have one power on the left, one power on the right with like bases, and I can drop those bases and set the exponents equal and solve. So subtract 4. Oops. I get 4x is equal to negative 6. Divide by 4. And I get x is equal to negative 3/2 because I want the reduced answer. All right, so it's your turn. I want you to do 20 on your own, so pause the video. 20 is very similar to 18, and so see if you can figure out what to do. Restart the video and check your work. All right, so 16 can be changed or exchanged for 4 squared, but I want to move 4 squared up into the numerator, so it becomes 4 to the negative 2. And then I also have times 4 to the 2x equals 4 to the 6x plus 18. So we're almost there, but we don't have one power over here. So we're multiplying like bases, so we need to add these exponents. So I need to add the 2x and the negative 2. So I end up with 4 to the 2x minus 2 equals 4 to the 6x plus 18. Now I can drop the bases and set those exponents equal. And solve. Subtract a 2x. And then subtract 18. So we end up with negative 20 is equal to 4x, and finally divide by 4. And you get x is equal to negative 5. And that's it. So good luck on your homework. Let me know if you have any questions.